Alright, this is for question number 12 and homework number 14. Talking about confidence interval part 2. Clicking into the problem. Let's see what this is about. Alright, researchers are interested in the effect of a certain nutrient on the growth rate of plant seedlings using a hydroponics grow procedure that utilized water containing the nutrient. They planted 6 tomato plants, just 6, and recorded the height of each plant 14 days after germination. Those heights measured in millimeters were 54.2, blah, 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 blah. So they gave you 6 different numbers. These are the heights of these tomato plants. So they want you to complete a parts A through D below. First, let's go ahead and create a 95% confidence interval for the population mean mu. So, alright, we'll do that. Now, for 95% confidence interval for the population mean mu, when you do not know the population standard deviation, you're going to have to do stat, t-stat, okay? You're not going to do z-stat. The z-stat will probably never really be used unless we are given a population standard deviation. Go with t-stat, click on one sample, and we got data entered in number 1, or column 1. So stat, t-stat, one sample with data. Click on the column, variable 1, and then tell them that you want the 95% confidence interval, and go ahead and hit compute. We got the answer. So the number is going to be 56.3 to 69.0. Nope, not that one. Forgot what was the number. This is the other work. Sorry. I'm going to close these. Where is this? Oh no, I think I lost it. Oh no, here it is. So 56.3 and 69.0. So that's how you will find the confidence interval for population mean. Got it. Name 2 things you could do to get a narrower interval than the one in part A. So if you want to get a narrower interval, we should probably increase the sample size. We should get a bigger sample size than just this. Remember, sample size, as you increase it, the margin of error will decrease. So that's going to result in the confidence interval to get narrower. So the first thing that I can think of is increasing the sample size. Get a bigger sample than just 6 tomato plants. The second thing we can do is we can probably to narrow our interval, we should be able to decrease the confidence level. So I'm going to go ahead and click on this one, decrease the confidence level. Okay, and increase the sample size, and that's the way to do it. Okay. Lastly, they want you to construct a 99% confidence interval. Now they're going up on the confidence level, so what I'm expecting is the interval will get wider actually. So let's take a look. Where did that go? Oh, over here. So 99% confidence interval. Stat, t-stats, and one sample with data, but this time I'm going to do 99%. And if you hit compute, ta-da, we got the lower bound to be, let me go ahead and just move it up like this so that I can go ahead and look at it and type it in. The lower bound is 52.7. Notice the lower bound is lower than what we had for the 95% confidence interval, and then the upper bound is 72.6. And again, that 72.6, the upper bound is higher than the upper bound for the 95%. So the interval actually really got wider. As you increase the confidence level, the confidence interval will get wider. Okay, and that is that. Why is the 99% interval wider than the 95% confidence interval? Well, it's because if you increase the confidence level, we will be multiplying the standard error by a bigger critical t-score. So the t-distribution critical value is smaller with higher confidence level. This is saying the exact opposite thing. I want to say the opposite thing. The t-distribution critical value is larger with the higher confidence level. That is it. That is it. Okay, so that will be it. And these are the great problems that will help you on, or maybe you already did data assignment 4. So these are the kind of questions that I asked on data assignment 4. So if you already got them answered, maybe the questions were just on finding the confidence interval, but that is how you would do this problem, okay? Oh, there's one more part. Let's take a look. On what assumption is the interval in part A based? Now, remember I said I was a little complaining because they only have, 6 tomato plants. And if I only have 6 for my sample size, that's just too small. I can't really use the central limit theorem, right? Because it's not 30, it's just 6. So what we are assuming is that hopefully the population distribution for these tomato plant heights are normally distributed. And also these tomato plants are selected randomly. These are random sample of tomato plants. So let's take a look at those two things. Data are obtained by randomization. I love that part. And all the data are within 2 standard deviation of the mean. I want something stronger. I want something to say that the population distribution is approximately normal. And I think it's the one right here. When you have a smaller sample size, not 30, you can't really use the central limit theorem. So what you are hoping is that the population distribution is approximately normal so that we can go on with this inference procedure, using that, the sampling distribution is normally distributed. So D will be the answer. And I think that's all of it. That was all of it. Definitely try the similar question, okay, Grace? And if you find anything else, you do let me know, okay?